So, hi everyone. This week I thought I'd talk about like the perfect s'more for my ratios. So, first off, I was talking about the graham cracker to marshmallow ratio. So I said for every one graham cracker, I need 2 marshmallows. So in this case, that is already the unit rate, which I demonstrated on this graph here is this little dotted line. So for every one change in 1x, the change in y I have highlighted there, and so in this case it's also the same as my proportion, because you see that 2 to 1, so up 2 over 1. And so in this picture I tried to show so each set that I would have. So in the table you can see the proportion of how it grows. So for the change in x or the crackers, you see you're always adding 1. The same for the marshmallows, you're always adding 2 with each additional s'more. So like I have the proportional amount, so 1 for the graham cracker, 2 for the marshmallows for the number of s'mores. So I also did like a little problem about if I had so many crackers, how many marshmallows I need. I probably should have switched this around so it was change in y over change in x to better reflect the slope. So I wrote a little note about that there. And I think you really see the proportional relationship in the slope here of the up 2 over 1 in that graph. And so then I did the same thing but with marshmallows to the pieces of chocolate. So for every 2 marshmallows, I'm going to need 3 pieces of chocolate. So I did a drawing like before where you can see the 2 to 3 for the proportion. Sorry, my cat's yelling at me. And so similar in the table here, you can see the x for the marshmallows increasing by 2 with each s'more that you make. So the number of s'mores times 2 is the marshmallows. The same thing with the chocolate pieces. It's going up by 3. So that's where you see that 2 to 3 ratio for every time x changes by 2, we see y change by 3. Which is also something you see in the equation here. So in the unit rate, so it'd be for every 1 marshmallow, I need 1.5 pieces of chocolate. So when we see like the 3/2, well it's 1.5, but we often think of the up 3 and over 2 kind of movement of the slope there. But we see, so that's our proportion of overall when you think for every single s'more. But you also have the unit rate going here, which isn't as relevant in the context itself. But you're still seeing the proportion in the slope one way or another, whether you're going up 1.5 1 or you're going up 3 and over 2. Yeah, and then I have another similar little problem solving thing here.